Yes. Well, I'm just watching. I'm just watching how it's filming.
There's live stream.
Yes. And you should be. Well, yeah. I wonder if I can see if it's running. He put it somewhere.
Hey everyone. Let's get started. Okay, welcome to our biggest Geek Night ever. And I know a lot of people have just recently joined Manchester Geek Nights. Manchester Geek Night is a monthly Geek Night event sponsored by TopWorks. We are trying to sort out the schedule for the next year. So if you have any suggestion or specific topic that you are interested to hear, or any specific person from TopWorks that you want to hear from, please contact us. We have two main events coming up. The first one is Key TV, happening at 17th of September in Manchester and 19th of September in London. Ian Cartwright from TopWorks is talking about insights from TopWorks Tech Lab focused on travel and transport. He's going to talk about the technologies like cloud, graph database, and Neo4j. And Richard Manners from Morrison's, he's the Morrison's client director. And he's going to talk about how consumer technology is transforming IT. We have sorted out the speakers for next Manchester Geek Night. We are working out on the dates, but we have the dev team from Manchester Tech Lab talking about the technologies and their achievements during the Tech Lab. TopWorks is constantly hiring, so if you're interested to join TopWorks, please look at our website at join.topworks.com or talk to any TopWorkers. We are looking for DevOps, poly-skilled devs, XD, QA, and any other roles. So please find someone from TopWorks and talk to if you're interested. We have Olivia here from recruiting. And please talk to her if you're interested. And send us feedback. We have 3 suggested hashtag MCR Geek Night is the new one we are using. TopWorks and TW UK North. If you want to send feedback about Geek Nights, you can contact me directly, founder@topworks.com. And you can also leave your comments publicly on Meetup group, meetup.com/Manchester Geek Nights. I'm going to hand over to Rebecca. Rebecca is our CTO. She's been working for more than 20 years on in this industry. And yeah, thank you very much.
Okay, thank you. Okay, so what I want to talk about is the notion of evolutionary architecture and talk about what it is and how we characterize it, and then try to give some very concrete examples of various techniques that you can use to address traditional architecture problems in a more evolutionary way. So, first I want to make sure everybody understands why you should care about this. I spent a lot of time with ThoughtWorks working with very traditional central architecture groups, and so I spent a lot of time trying to explain why we think taking a more evolutionary approach to architecture makes sense. I also want to describe what I'm talking about in terms of evolutionary architecture, and in particular distinguish it from emergent design. There is obviously a continuum between design and architecture. I'm not going to give you a very precise definition, but I will give you something to be going along with. Then I want to lay out a few principles of evolutionary architecture that allow us to think about how we can architect a system to be more adaptable, talk about a few of the techniques, and then try to how you tie all those things together. So, the first thing, why should you care? Well, I think the first reason is the expectations in terms of pace of change are increasing rapidly. It used to be that it wasn't too bad to think about, oh, well, I can only deploy every 3 months or every year. But the expectations that customers have, that internal people have, that even the business has on how rapidly we will be able to get something out the door, those time frames are coming back and continuing to scale back even further. So we have to be more ready to change things. Even worse in some ways for our employers, business models are shortening. Once you actually figure something out that's unique and innovative, you don't have the same kind of runway that we had even 10 years ago. And it's much harder to predict the future. One of the things that I've often found is central architecture groups get put in these wonderful positions of having to figure out, well, gee, I think this is how something's going to be used in 2 years. And that's not very effective. It wasn't even effective 10 years ago, and it's even less effective now because we don't really know what the future is going to look like. Also, a lot of ideas, they have a very short runway. You'll see an uptake curve where things are kind of floating around. All of a sudden they go viral, and then in a month's time they're dead. If your business misses that upswing, you've missed the vast majority of your revenue potential because you just can't wait to be able to scale. So, hopefully, you know why you should care. So what do I mean about evolutionary architecture and emergent design? Well, the first thing I want to distinguish between is emergent and evolutionary. Emergence is something that you don't really guide, you just discover. So if you think about code, for example, as you look at how features get implemented, and you're going to look at something and say, oh, wait a minute, I can refactor this into something that's more reusable. That's emergent. You didn't do anything specifically to get you to the point where you made that decision, okay, now I'm going to refactor. You went along and did things and observed, now my landscape has something that I can extract. Evolutionary, on the other hand, is guided. And so what we're talking about is you have some goal in mind, and we'll talk a lot more about what that really means, but you have something that constitutes goodness for your architecture. Now, that might be very specific to the application. Does it need to be highly available? Does it need to be scaled to massive loads? Is data security a particular problem? Each one of those applications will have a different profile of what constitutes a good architecture. Some might be more specific to your organization. Everything has to talk to this particular system that provides reference data to it. So that's going to be a particular characteristic that is more common to the organization as opposed to the particular application. But whatever those characteristics are, they define for you what constitutes a good architecture. And every time you make an architectural decision, you should be looking at it in the context of this goal that you have set for a good architecture so that you can continue to move towards it, rather than trying to set in advance, these are the specific implementations for the characteristics that I want for the architecture. So that's the distinction we're making. You can characterize what constitutes a good architecture without specifying, and oh, by the way, it has to be implemented in IBM WebSphere or Active Directory or whatever. So, design versus architecture. Again, this is a continuum. When I talk specifically about design, we're thinking very much at the object design level, at the module design level. And when I'm talking about architecture, I'm primarily focusing on how components talk to each other. And I'm using components with a very small c. I know it's an overloaded word, but I have not come up with a better one yet. What are the blocks that are on your diagrams at various levels of granularity? And how do those blocks interact with each other? That's what the architectural concerns are. Sometimes those architectural concerns are characterized in terms of the ilities. Is it maintainable? Is it extensible? Is it recoverable? Is it traceable? Is it da-da-da-da-da-da? The ilities. So that's design and architecture. Now, obviously, if you've got a very detailed object chart, you're going to have blocks on a diagram that correspond to each other. That's probably not at the level that we're interested in here, but it may be if you have an organization that is pushing you to think about reusable components. Okay, so evolutionary design or evolutionary architecture versus emergent design. So when we're talking about emergent design, that means as you're going along developing code, what kinds of things are you extracting? What kinds of things are you finding that are reusable, that are common? What kinds of things are you uncovering that perhaps tell you you need to think about your object relationships differently? That's emergent design. That all comes out of what you discover along the way. The evolutionary architecture that we're talking about is how do you make some of those larger decisions about what technologies you should use? How should these various components communicate with each other? Those are the things that we're talking about in terms of evolutionary architecture. So, what are some principles? I'm going to run through these really quickly at first, and then we'll dive into each one a little more. The first is a very important one. I prefer to call this the latest responsible moment. Martin Fowler keeps beating me up because everywhere else it's the last responsible moment. But whatever. This is when you're supposed to make a decision. Architect and design for evolvability. There are many characteristics that you can think about when you are thinking about how I'm going to not only architect my system, but also design at the more detailed level. And focusing on this notion of evolvability gives you many different benefits, and we'll talk more about those. Hostel's law. Hostel's law, paraphrased, gives us guidance about how systems should communicate with each other. And we'll go into that in more detail. This is a ThoughtWorks talk, so it has to have something about testing. But in fact, one of the things that we have found is that if you think about testability, when you're making tools choices, when you're making architectural decisions, you actually end up with quite a nice architecture. Because the things that make things testable also tend to make them easy to understand. And finally, Conway's law. And again, paraphrase, this is whatever you design is going to reflect your organization. So if you don't want your product designed that way, change your organization or change your product, because you really don't have a choice. So these are the principles, and we're going to go into these in a little more detail. So the last responsible moment basically says, delay every decision you can as long as possible, but no longer. Now, of course, the most common question is, how in the world do I know how long I can wait? Well, first, why would you wait? You're going to obviously maximize the amount of information you have available to you to make your decision. But more importantly, you're going to minimize the amount of technical debt that you accumulate as a result of making the wrong decision. Now, we normally think about technical debt as, okay, well, I just threw the code together because I had to get it out the door, and so I now have crufty code and I need to go back and refactor it. Sometimes technical debt is also characterized as, I haven't upgraded my version of PeopleSoft in the last 11 years, And so I've got to do something about getting it up to the most current version. But there's another form of technical debt that's quite important. And if you step back and think about the debt analogy, technical debt carries interest. And interest just adds to the debt. If you think about that in the technical context, we can think about technical debt as drag. And anytime you've introduced a tool when you don't really know that you need it, it is going to complicate how you write your application. And every single line of code you write is going to cost a little bit more. And so if you decide early on, I need this heavyweight queuing system, when in fact you didn't need all the bells and whistles of the heavyweight queuing system, you could have used a much lighter queuing system. Every single piece of code you wrote along the way paid a surcharge for that decision. And so we're going to minimize that if we delay the decision. Again, what is the last responsible moment? How can I decide what this is? And for this, we come back to those architectural drivers that I was talking about. We had an application once. It was a trading system. And every time I say trading system, everybody thinks high volume, got to pump the transactions through. This organization didn't care about that. In their wildest dreams, they would never have more than 2,000 transactions a day. Not an hour, not a minute, not a second, a day. They didn't care how fast they were. What they cared about is that you never ever lost a transaction, because every single one of those was worth billions of dollars. So we didn't spend our time worrying about high performance. We spent a whole lot of time focused on what was the communication channel, how are we keeping these different systems in sync, what pathways these messages have to go through, and how can we make sure they flow. Anything that had to do with that communication and that persistence and keeping track of messages was a high priority to us. And that helped us to determine when we made decisions, because anything that is that important is something that's going to have such a tremendous influence on your entire application that you probably need to make that decision earlier. You need to think about where are the sensitive points and what do I have to do to ensure that message is always going to make it through, and if it doesn't, I know it as soon as possible. So you think about, in this application, what are the things that matter to me, and that influences. Now, yes, this still comes down to taste. This is an art, not a science. I can't tell you that on January 27th, this is the time you need to make the decision. This is something that has to be developed over time. But the key point is, if you don't feel like you know, and it's just going to be, okay, well, that one looks good, that's probably the wrong time to make the decision because you don't have enough information. And if you can't even get farther than that in your decision-making process, you probably don't know enough to really make a good decision, and that means the probability of you making a bad one is quite high. Okay. And we call this evolutionary because it is based on this fitness function, this architectural fitness function. What constitutes goodness in your architecture? And I realize for you in the back, this is hard to see. He'll be putting the slides, but this says basically evolutionary, neither emergent nor based on guesswork. One of the things that I try to do is allow people who are doing architecture to rely on evidence rather than crystal balls, because I don't know about you guys, but my ability to predict the future is not very good. So, next one, architect for evolvability. Well, what does this really mean? We want to concentrate on how we are going to structure the application to make it easier to change the parts as much as possible in isolation. When you start talking about enterprise scale applications, you might have hundreds, if not thousands, of developers. And you can't have one big team with one massive scheduling that goes on and says, okay, this developer working in Bangalore, India, and this developer working in Beijing, China, and this developer working in Manchester, this is how you guys are going to sequence your work. That is not practical. So we have to do what we can to allow these different teams to run independently while learning very quickly when things have gotten out of sync. So the first thing this requires is a sensible breakdown of functionality. I know this sounds blindingly obvious, but the number of times I've had to explain to people, don't just take all of your front end and send it off to India and have your database done in London and have your business logic done in Manchester, because that means for every single piece of functionality imaginable, all of the teams have to be synced up. It seems like it should be logical to split it up that way, but every single one of those teams can declare success and that application can still not work. So you have to think about functionality differently. You have to break it up in such a way that you minimize those interaction points. It doesn't, this, like I say, it sounds obvious, but the number of people who get it wrong is unbelievable. The next thing is consider your data lifecycle and, importantly, your data ownership. We've been in situations where you had to go to the chief financial officer of a Fortune 100 company to find someone who had enough authority to sign off on a data migration. Do you realize how hard it was to get on that guy's calendar to sign off on a data migration? That's because we never really think about how we combine data together. And you've got customer data and order data and accounting data and all of those things smushed together. And as long as you've got that, you have got ownership that has to go up to the C-level. No one else has the authority to sign it off. So when you think about this, think about what is the life cycle of data, what is the ownership of data, both from an organizational perspective and a business perspective. Take that into account when you're thinking about how am I going to chunk up my functionality. Yes, you might have a bit more complex data landscape, but that's more flexible, and there are more solutions to that problem than making that architecture too dependent on it. Appropriate coupling. This is not loose coupling, this is appropriate coupling. Based on your architectural drivers, you might have two pieces that you would really like to have loosely coupled, but the performance requirements are such that you have to tightly couple them. There's nothing inherently wrong with tight coupling. There's inherently wrong with doing everything tightly coupled. It's inherently wrong to stumble into tight coupling that you don't need because it does reduce your flexibility. So you need to think about all of those interaction points and how do I need to define that interface on the basis of what is most important to my application. The lightest weight tooling and documentation possible. Again, this does not mean everything has to be lightweight. There are reasons for some of these heavyweight tools. And if you're using them in the right situation, that's great. But you need to be using them for the right reason. Not, I hate to say it, that somebody was out on the golf course with a salesman and thought, gee, this sounds like a great technology for us to use. Think about what it is that is in fact necessary. One of the exciting things about the NoSQL revolution is people are starting to think, maybe I don't need full add-in all the time. Maybe I don't need all of the strength of a relational database all the time. It used to be, oh, you have to persist data, therefore it will be in our relational database. And it will be backed up, and it will have all of this other stuff that goes along with it, even if there's absolutely no reason for that to happen. If you persisted, it must have gone into a database. Think about what you actually need in that particular situation. If you need a heavyweight tool, great, use it. If you need a lot of documentation to satisfy regulators, write it. There's nothing in what we talk about with Agile and anything else that says never do this. But do it because you need to, not just because. What does it mean to develop for evolvability? One of the things that we have found, and we're still evolving this, is there are metrics that can help you understand how maintainable your code actually is. And the first step of understanding how maintainable something is how understandable it is. And this isn't just to the person who picks up your code in a year's time, but this is you when you pick up your code in 6 months' time. Because you won't necessarily recognize it anymore. You might eventually remember, oh, I remember why I did that, because it took you 36 hours to figure out how to fix a particular bug. So that might stick in your head a little bit more. But in general, when you come back to your very own code, 6 months later, you have to go through that re-understanding. So there are metrics that tend to be a composite of size of class, size of method, nothing terribly surprising. Cyclomatic complexity. We've come up with a blended metric that in general tells you where your hotspots are, how good your code is in terms of how easy it is to understand what's going on. Now, I very often then get asked, okay, well, if I've got this ball of mud, where do I start? It's all fine and good for all this greenfield development, but I've got this thing that exists. How do I know where to start? And I try to base it on three things. First, yes, you run the metrics, and you find out where the truly horrendous parts are. Then you look at your source control system, which hopefully you have. Unfortunately, there are still people who don't know what a source control system is. And you find out what are the modules that are getting checked out a lot, because that's where your changes are occurring. And if you've got something that's a ball of mud and is getting changed a lot, that should be a high priority. The third thing I do is ask, which part of the system, when it's getting changed, do the QA people get nervous, the users get nervous, or the ops people get nervous? Because that's someplace that holds those landmines that nobody remembers where they are anymore. So that's probably another candidate, particularly if it's high up on the ball of mud list. And the final thing is talk to the customers, the business users. Where do they think this is going? It may be that for the last year they've ignored things in the customer database for whatever reason, but all of a sudden their new marketing campaigns are going to put a lot of pressure on that. Ask them where they see the functionality going and marry that across. Find those hotspots. I would love to be a purist and say we should wipe out everything that has bad metrics. That's not practical. If you focus it on that, you can make a case for why you're actually spending time paying down technical debt. You can also answer the question of how do I know that it's not going to come back? If I'm a CIO and I've finally been convinced by my development team that I really need to do refactoring, the question that I very often get asked, okay, how do I know in 6 months' time you're not going to come back and ask me to do this again? And this is this next point. You measure continually and you watch the trends. You may not act on any particular number, but you should act on the trend, particularly if you're going along like this and all of a sudden you go like that. What happened when you went like that? This could be performance test metrics, these could be code quality metrics, all of these things, you should pay attention to trends. There will come a time when you might want to pay attention to a particular number, but trends are almost more important because they tell you when something has changed. Maybe it's something in your process, maybe it's something in the application. We found evidence in some of the historical research we've done on our code submissions that ThoughtWorks has been doing for 20 years. We have a database that has a subjective evaluation of the quality of code and the code itself. And we ran the metrics. And we found that, in fact, there is an inherent complexity of code, not surprising, but that inherent complexity reflects itself in the metric. And it is quite possible to have too good of a software quality metric because that level of complexity in the code is not adequate to actually express the problem. So you want to focus on trends, and that will tell you when something has changed. Then you can think about what to do about it. Maybe it's because you've gone into an area that all of a sudden is more complex, and so the numbers have to go up. Maybe it's because something has changed in your process, and you're just writing sloppier code. Maybe you're getting into an area that you don't understand very well yet, and so you've got a lot more proliferation of code until you see what the pattern really is. There can be legitimate reasons for those metrics to go south, but you want to know that you've thought about why it is that that's happening. And you can't do that unless you do the trend analysis. Reversibility is another key component. And this is how easy or difficult will it be to change my mind? So if there is a decision that you've gotten to this last responsible moment and you feel like you need to make now because of the impact it has on the system, but you're not completely convinced it's going to be the right one, spend a little time thinking about what would happen if I changed my mind. Maybe that means you're introducing an abstraction level. Maybe it means you're isolating things and putting in a message that you wouldn't put in otherwise. There are all kinds of things that you might do to make a particular decision reversible. But if you think about that and keep in mind that you might need to reverse that particular decision, if you do have to reverse it, it's much easier by definition because you thought about it. You don't want to do this for everything. YAGNI still applies. You ain't going to need it. But YAGNI is not a license to ignore what might possibly happen. It is not a license to ignore what you might know. YAGNI applied in this context means think about how likely am I going to care if this is the wrong decision? How likely is it that I got this so horribly wrong that it will be worth it for me to change my mind? And if you get that kind of answer, you probably do need it, if nothing else, to protect yourself from that possibility. So don't build it in for everything, but build it in where you think you need it. The last time I gave this talk, actually, in Vancouver, Canada, somebody put their hand up and said, actually, that was one way I got credibility with my team about the decisions that I was making, because I told them up front, I'm not sure about this one, so let's put in some protections so that maybe I can change my mind. And in fact, he had to. And they trusted him more on the other decisions he was making, in part because of that, and the fact that he had the guts to stand up in front of his team and say, sorry guys, I blew it. But at least I thought it was possible, and they were ready for it. So, what about Postel's law? Postel's law, paraphrased, is first, be conservative in what you send. When you're talking about any kind of information exchange, you are in fact establishing a contract when you put information out there. Whether it be through an API, through a database, we still have lots of database integration out there, in a message, all of those things, you are implicitly establishing a contract that if you put something out there available, it's going to be available. So you want to be conservative in what you send. You want to know that that's something that you feel safe to put out there in that context. And then be liberal in what you receive. If you don't need a part of the message, don't look at it in any detail. Why? If all you care about is a postcode, because maybe you're doing some kind of location-based service, why should you be validating the name and address and telephone number fields? All that means is that if they change those fields, your application needs to be changed for no reason other than the fact that you looked at something you didn't need. So be liberal in what you receive. Now, you still have to protect yourself about all the different kinds of security holes that come in. But you want to pay attention to what are the pieces of data that actually matter to you. Only validate what you need. This actually holds for any kind of information exchange. Don't just think about this in terms of messages. It's very easy to just focus this on messages and not think about it in any other context. Think about any time you've got independent pieces of software that are exchanging information. Think about this law, because that allows System A to change more relative to System B. Now, this is not going to eliminate it completely. If I have to change something about postcodes and you're requiring postcodes, eventually you're going to have to change. There's no way of getting around that. What it does prevent is this consuming application having to change because something else was changed. Finally, since you are basically establishing a contract, you want to think about these information exchanges in that way. And it may be that if you do have to put out a lot of information for whatever reason, you might want to think earlier rather than later about some kind of versioning system. Depending on how much knowledge you will have about the consumers of your information, you might think earlier than you might otherwise, what am I going to do about versioning this information exchange? Is there a way that I can make it less catastrophic for people who are consuming this information? Again, you don't want to do this everywhere. YAGNI tells us we don't want to do this everywhere. Think about what is the spread of this information, what is the volatility of this information. And that's Postel's law. Architect for testability. It's fascinating, really, that if you think about how testable a system is, how easy it is to automate testing of a tool, how you will tend to get a better architected system. This is something that we found over and over again. And I'd love to say I thought of this in advance, but this is what we found. As people focused on separation of concerns, because it's easier to test. Do my tests sound like A, N, B, N, C, N, D, N, E? Well, that's a smell for a test. It can be a smell for an architecture as well. So if you think about how easy or difficult it is to properly test your system, you will end up with a better architected system. So what are some of the implications of this? Business logic within messaging layers is inherently difficult to test. It's also, and I know the big message bus vendors won't like to hear this, but we don't think that's the right way to architect systems. You are making your system less flexible when you put the information in there, even though, in theory, that shouldn't be the case. But it's also difficult to test. So guiding this, how easy or difficult is it to test, actually leads you to a place where you have a more flexible architecture. This can also give you guidance on this sensible components. This says business sensible components. When you're talking to your business user and they're describing to you what they want to do, and when they're talking about the flow of information or the way a process will proceed through the business, they're going to use business terms. That's how they talk about it. They don't know what the objects are, what the database records, or anything about that in the system. They're going to talk about it in business terms. And so if you're going to start to write business understandable acceptance tests, you're going to need to have some way of expressing this in business terms, and that's going to guide you in how you actually chunk up your system. We actually had a client here in the UK, the CEO of the organization, granted it was a medium-sized business, not a Fortune 100, but the CEO of the organization read the acceptance tests every month because it told him exactly what his product did. Because all he had to do was go down to the development room and see that the build was green, and he knew exactly. He didn't have to listen to the salespeople. He didn't have to listen to the designers. He knew exactly what his product did at any given point in time because he could understand the tests, because the tests were written in a way that he could understand. And that had implications for the way the entire system was designed. There's another aspect. This says testing at many levels, including contract. I'm going to talk a little bit more about contract testing. But we think about unit testing. We think about acceptance tests. We think about smoke tests. We think about integration tests and automating all of these things. So this particular architecting for testability has impacts in the small and in the large when you think about the context of your enterprise asset. And finally, you need build pipelines to support the volume. One of the things that we've learned, if you're going to do something a lot, you want to automate it. Anytime you start doing something like this, you are making your testing process more complicated. You want to know that it is as inexpensive as possible to run this. This is going to imply a pipeline. You're going to want to think about what the stages of that pipeline are and how often different stages run, but you want to think about this in the context of a build pipeline. We are moving past the point where you can just have a CI server running your unit tests, and then a miracle occurs, big cloud, and something goes into production. Okay, Conway's Law. Again, slightly paraphrase, the organization's design, and most importantly, their communication channels, are reflected in the design of their products. That's just the way it happened. Now, the short version is, if you've got 4 groups working on a compiler, you're going to have a forecast compiler. That actually came from someone who was writing a compiler and was given 4 separate teams to implement the compiler. And he understood Conway's Law and said, therefore, I will have a forecast compiler because I'm going to end up with one anyway, so I might as well start thinking about it in that context. Interestingly enough, when we go into clients, all I have to look at is how well do the different groups communicate, and I can almost reliably predict, this is one way I can predict the future, I can almost reliably predict where the integration problems are going to be. Because if the 2 organizations don't talk to each other, it's almost given that System A and System B won't talk to each other either. And so when you look at your own organization and when you're looking at taking on particularly an integration challenge, look at the way the people in that organization communicate with each other. Because the broken communication channels amongst people and amongst groups will reflect itself in broken communication channels in the systems. The kind of silos that I was talking about earlier, do the front end here, do the back end there, do the business logic there, those result in integration nightmares. Some people are nodding their heads, they've seen it before. But these other kinds of silos often result in that same kind of broken communication. A database group that sits off all by itself and accepts things that are tossed over the wall and throws things back, those kinds of silos can get you into trouble as well. So you want to look for where you have difficult. It might not be broken, but it just might be hard. Or in fact, at its worst, you've got two organizations at war. And those are the ones where you know it's just never going to get in production on time. And so the summary is, and I'll read this for the folks in the back, if you don't want your product to look like your organization, change your organization or your product. There isn't really any other way to get around this problem. So unfortunately, even though we're all geeks, and we like to think about code, and we like to think about devices, and we like to think about fun things like that, when you get to an architectural level, you also have to start thinking about that messy people stuff and the organization and all that kind of nonsense. Because unfortunately, it has an impact on the fun stuff. Okay, so what are the techniques? Database refactoring, continuous delivery, and contract testing. Of these three, these first two could be a day-long workshop. So you're not going to get the details around this. I just want to give you the basics of this because in particular, the first two have a lot of impact on the day-to-day work that architects do. Contract testing is something that we don't see enough of, that I actually think has the ability to make organizations more effective in terms of keeping things going in parallel. So, database refactoring. This is a very simple concept. If you've got a big database change, break it up into smaller things. In fact, that's why it's called database refactoring. Except for the way we always misuse the refactoring term now, which basically said, I've got a messy code base that I need to clean up, so I need to refactor it. Well, refactoring actually has a precise meaning, making very small, individually testable changes, and when you do lots of them, eventually you've moved your code base from A to B. This database refactoring is the same notion. You want to take that massive database change that you have to do and break it up into smaller changes. Each one of these changes can be thought of as either a pair or a triple, depending on how you want to talk about it. It's what is the actual change, the refactoring of the database, what you have to do to migrate old data to new data, and the third, if you want to include it, is what changes you have to make to the code. Now, the nice thing about these changes is they compose. If you make the changes sequentially, first I'm going to make this small database change, do the small database migration, make the changes to the access code, do the next one, you can compose these all together and in one step go from this point to that point with small testable steps along the way. Now, anybody who's been working with databases long enough, you know data migrations are horrendous. This allows you to test those data migrations in small chunks, and you can start to get some insights when you see where it breaks down. What exactly is the problem in your data that is resulting in this data migration failing? It's much easier to do this when you're making small changes, just like it's much easier with continuous integration. When your unit test fails, you know what change it is that made the world look so ugly. And of course, you use version control to keep track of the changes. By checking these things in, you have a way of knowing, okay, this database is at this level. These are the scripts I need to run to get my crusty old UAT database from version 1 to version 89. Even though your integration test server may have gone through all kinds of intermediates, you know these things all compose, so whatever state any given database is in, you know you can upgrade it. And thus you can apply it to the various environments on your path to production. Again, regardless of where an individual database sits, you have all of those scripts to bring it up to whatever your current state is. An interesting thing, by the way, these same principles apply if you're dealing with NoSQL databases. The book literally was actually written for relational databases, but the same basic principles apply. The kinds of refactorings you need to do in a graph database and the kinds of implications that has for migrations and code changes are different. But if you think about migrations or database changes in the same way for NoSQL databases, you'll see it leads you to the same kind of conclusion. Continuous delivery, whirlwind tour number 2. So, the first thing about continuous delivery is you want to automate just about everything. The first thing, if you want to think about continuous delivery, where are the pain points in deployments? You have some poor guy sitting up at 3 o'clock in the morning trying to type in all of these commands, even if he has this wonderful little script. I'm not very good at 3 o'clock in the morning when I had to do these things. You're going to make a mistake. With the best of intentions, with the best of instructions, every once in a while you're going to mess it up. So you want to automate it. You want to automate your configurations. You want to automate your environments. You want to automate your builds. You want to automate your deployments. You want to use continuous integration. You want to automate all of this stuff. Because once you get the script right, it just works. If you automate your environment configurations, that also means that when something breaks in production, you can actually recreate the environment in which that bug occurred. How many of you have had to stay up late trying to figure out why something only breaks in this particular box in production and not that particular box in production when they're identical, aren't they? Yeah. Been there, done that. Automate your testing at all levels. So basically, this is the heart of continuous integration, continuous delivery. Everything you do on your path to production needs to be automated, and that means that it can run fast. Because deployment should be boring. You should not be celebrating the fact that nothing broke. We'd love to have a party about all of the good stuff we just deployed, rather than, oh my goodness, thank you. I did not break anything. The CEO doesn't hate me this month. That should not be what is being celebrated. Deployment should be boring. Now, in a lot of organizations, when I talk about the continuous delivery, they said, you don't mean to tell me I have to allow a developer to check in code and it'll automatically go into production. What will my auditors say? What will the stock market say? All of this. Just because you can release at any time doesn't mean you have to. There is nothing you will find in that continuous delivery book that says there's anything inherently wrong with giving the business the final say-so. Nothing. You can have a manual gate. What it's all about is you want to be able to do it as quickly as possible. You want the business to be in control of when something goes out. And you want them to know that it is as risk-free as possible for them to deploy things. So if a security patch gets exposed, you want to know that you can very quickly get the patch installed so your systems are not at risk. You want to know that if the regulations change, that you can safely put out the code so that you don't get fined. So just because you can doesn't mean you have to. But if you can, what you've done is you've taken out the constraints for doing things when it is best for the business to do them. And oh, by the way, you no longer have to panic as you're trying to type something in at 3 o'clock in the morning, worried that you're going to get it wrong. Okay, final thing, contract testing. If you think about two systems that are working together on something but being developed independently, and you think about what the Agile principles tell us, one of the things they tell us is we want to know as soon as possible when something has gone wrong. So what this contract testing is really all about is an acceptance test for the interface between two systems. Another way to think about this is we're going to document the assumptions that System A is making about System B. These are the things that I expect your system to give me. This is how I expect your system to behave when I do this. And that means you can change your system to your heart's content. as long as you keep running those tests and they don't break. And as soon as they break, you pick up the phone, you send me an email, you ping me, and you say, test number 42 just broke. Let's talk. And we've been able to run completely independently up to that point because you're just churning along, and every time you run that test, you're verifying that I don't care about what you're doing. And as soon as that test breaks, that means we have to talk about it. Because it may be you are fundamentally changing something that is going to be a problem for me. It may be easy for me to fix, it may be hard for me to fix, but we've caught it as soon as possible. The other thing this does is actually protects you from that person who's been around since the dawn of time, who's the only one in the entire organization that knows how that old crusty mainframe system number one impacts payroll, or impacts ordering, or impacts all of those things, because those things get documented in a test. And that means if something happens to that person, you can actually still change those systems because now you understand what it is about that old crusty mainframe system that makes everybody feel sick every time they think about it. So by documenting these assumptions, these teams can be independent. This also works really well for third-party suppliers. If somebody's writing an application they're going to deliver to you, you have this contract. And you say, don't send me anything until it passes these tests. And that way you know exactly what you're getting. And you know you're not going to waste a whole lot of time installing something that is fundamentally inconsistent with your expectations. This is also a way, if your shop is trying to be agile and they don't want to be agile, you can continue to feed them things that they can use to verify their system. So this allows as much independence as possible by simply documenting these assumptions, maximizes parallel and independent work, and you can use this in conjunction with Postel's law. Think about, I want to minimize the amount of stuff that's in there. If there are things that I don't have to assume you're going to do for me, I'd prefer not to. I'd prefer to be able to do those things myself. So using this in conjunction with Postel's law will help guide you in thinking about what should that interface really look like. And as I said before, this is actually one of the traditional roles played by some enterprise architects that I've known. They were the only person really in the entire organization that understood how all of the different moving parts of the IT world in that enterprise work together. By using some of these things, you can start to transfer some of that knowledge from the head of the enterprise architect into a set of tests. Make some of the enterprise architects a little nervous because they're less indispensable, but that's still a valuable role even if you have that knowledge captured in a test. So, whirlwind tour of evolutionary architecture. What have we really talked about? The first thing, we need to define our architectural fitness function. What is it about your enterprise, about this particular application, do you care the most about? Because that's going to guide all of your particular decisions. People often ask, from an architecture perspective, how much upfront work should we do? This is a big one. Think about what are the characteristics of the system that will guide your architectural decision making, will guide your tool selection, might guide your package selection. This applies equally to package work. Think about what it is that matters to you, first and foremost. Once you have that, that gives you the basis to think about when I need to make particular decisions. What are the impacts that these are going to have on my critical areas? Understand the various forms of technical debt and understand what you can do about it. Implement evidence-based reuse. The number of enterprise architecture groups that I've dealt with, when one of the performance criteria they had was the number of times their reusable components were actually reused, most of these people, when they told me this, they were trying not to cry. Because you can't, sitting in a central architecture group, responsible for the architecture for 50,000 developers, know exactly what all those 50,000 developers are really going to need. So this provides a basis for that evidence-based reuse, as well as providing protection for when you haven't figured out what that reuse should actually look like yet. And create and maintain your testing safety net. Architectural changes can be pretty catastrophic. This is often the argument we get from people, well, I can't do evolutionary architecture. If I have to make a change, it will be catastrophic. Well, if you've got the right kind of safety net, changes that could be catastrophic aren't, because you're ready for them. And the whole premise of Agile is to make sure that you are ready for things to change, you are expecting things to change, rather than praying that they won't. Thank you. Does anybody have any questions? Yes.
Let's talk. I've got a question. It doesn't comment. The comment is that I had one case study where I was running a design online as an architect, online a lot of probably very different directions to how that goes.
Mm-hmm.
And just to kind of put some context, how the vendors trying to some vendors trying to put in their bits of the proper part, yes, the vendor trying to put business right. And kind of like as a testament to that, I've also had migration projects and had to come in exactly the right point, sort of object that you looking at one go like it before. So one of the basically I looked at trying to align everything like find out bottom measures that's not just that maybe it's good vendors doing DSP stuff in house actually wasn't that complicated. But we tried to discuss in fact in the data bus by using view as a kind of design that the example is that I have this is not going to be so right and with the company at 22.5 million acquisition that's a really good number. So to kind of prove the point that this stuff that actually works. But the second bit is I don't see myself as too much of a difference between emergence and evolution. So I get the reductions. To me, the guiding part of it is just being a bit lean or just one step ahead. Not trying to emerge. So, because the question I have really is where is the evolution and emergence continue? Where one starts.
Neil Ford and I actually had this argument because he was talking about emergent architecture, and it is a continuum. If you think about it, we'll think about it in biological terms. At the base level, it is, do you live or die? Okay. But as soon as you get past that base level, really emergence doesn't go any further than that. It's either you survive or you don't. But when you start looking at the more complex parts, the whole nuance of what constitutes survival changes. It's like, okay, well, the peacocks, they develop this wonderful tail for the males to show off. The opposable thumb, which makes it easier to do things. When you think about what it took to develop our sense of eyesight, it's a lot more complex than simply thinking about, okay, am I going to live or die? So, yes, there is a core that is very similar. The other thing that I will say, and this is where I think it's easier to describe in architecture terms, you have a basic set of rules about when should I refactor, what does a clean code base look like, that is pretty much application independent. However, when we're starting to talk about this architectural fitness function, one of my counterexamples to the example I gave earlier, this same organization had a sandwich ordering system. As a convenience to their staff, they had a system where you could type in your sandwich order. Now, they had about 200, 300 people in the building. Not a heavy user base. It was not catastrophic if the sandwich ordering system was not available. This was in central London. There were plenty of places that they could go to get a sandwich. So the characteristics of what would constitute a good architecture for the sandwich ordering system were completely different, even within the same organization. And so this is what we're saying is, yes, there might be common things about what constitutes a good architecture, but there are going to be some things that are specific to your organization, and specific to the application within that organization. So it's going to be much more specialized than just the base level. Is it pretty or not? Is it clean or not? And that's to me the easiest way to think about the distinction is from the perspective of emergence, your fitness function never changes. Evolutionary, your fitness functions are different in different situations. And that's why you have to think about things a little bit differently. You have to decide what's important to you initially to come up with that fitness function. Does that make sense?
Yeah, kind of. But I think the difficult one trying to put my head around, even though we may evolve a design, we're still using a set of tools which we have that constrain us in some way guide our that comes, even though we may not think about the design at all, that
Mm-hmm.
So my point is more with
We can probably we can probably argue that. Okay, I had one over there and one over there.
So if the idea is more that it's like adaptable rather than evolutionary, so that it's just working with an environment that's constantly changing, just as the business is changing with its environment, there's a key idea which is you'll see evolutionary fitness function, right? That's a changing organic thing that changes as the business model changes. But that's adapting rather than evolving. There might be an infinite number of pathways in which it can adapt. So the tools you're making when you're thinking about the initial structure is one where you're getting the idea of enough adaptability within the constraints of the world in which you're born, with this idea is born, and that's the constraint of time and energy. But that allows the possibility of certain evolutionary threats to exist within the initial construction. Is that what you're saying?
Adaptation can go many different directions.
Right.
And from any given point, you can have various adaptive paths. And yes, all of this is happening in the changing context. So that's in part what is driving the need to choose a path.
Yeah.
I talk about the fitness function as a way of deciding which one of those paths we in fact want to take.
Right.
Because making this particular decision has these consequences relative to my vision of what I'm trying to maintain with my architecture. And if I go this path, it has this set of consequences. And then I analyze what are those consequences relative to what I'm trying to achieve and decide which one is better in this context, keeping that goal in mind. So that's why it's not just adaptation.
So the testing tools themselves, the testing is the actual way in which the environment is monitored, the way in which you can...
That's one way of looking at it, yeah. But only an aspect of the environment, because the business context is changing, and we don't necessarily have, we haven't yet developed a way to test what it is our business is going to want to do next. So, but within the context of the system as it's been built, it is monitoring what are those external influences and how those are changing and what that might cause.
Yeah, like a browser speed.
Sure. Yeah. Okay, we have a push back there.
I'm not sure if this is a actually, I was going to ask what happens when the fitness function does change and shift away with more data to something like what would be a good outcome.
That can happen. Much like the decisions that are made in groups. So hopefully, probably, we'll start with this. Probably, if this is one of the guiding aspects of your architecture, what I really care about is data security. You're not likely to no longer care about data security. So the things that were really influencing your architecture in the past, it is possible, but it is unlikely that all of a sudden we won't care about security. It's possible that computer performance will take some enormous leap so that a performance concern isn't really a concern anymore. Possible, but not likely. What you're more likely to encounter is something that you didn't think you had to care about before, that now becomes critical to your decision making. Maybe it's a change in the regulatory environment. The way the health information protection systems changed in the US a few years ago had enormous impact, because there were all kinds of data protections that had to be put in a very specific way that weren't really that important before. And so that's the more likely assumption that's going to change, is something that didn't used to be important that now becomes important. I would assert that if that's really the change that's occurring, that is no more or less likely to happen if you're taking an evolutionary architecture approach than if you were thinking 5 years ago about what your architecture should look like, whether or not you would have taken that into account. And I think the fact that you have the testing safety net, the fact that you have the techniques for thinking about how these systems are interacting with each other, and you're thinking about proper encapsulation, will mean that the impact of those assumptions changing will be less. Can't do away with it. You know, there are no silver bullets in here. But by following this, the impacts of those assumptions changing, I think, will be lower. Not guaranteed, but that's, you know, probabilistically, I think, you know, you'll be in better shape. Yes.
In a similar vein, how do you realise where the point is to say your assumption, your key assumptions of what is important for your architecture? If those haven't really changed, but at what point do you then kind of look at whether the system is still capable of evolving at the rate really that you need it to still keep up with the business's goals or requirements? You know, if overall security performance concerns are the same, but generally the pace is dropping, how would you use tooling and metrics and so on to measure at that point at which you just go, right, this needs to be rebuilt, or something big has to happen?
Couple ways. Number one, a lot of those are actually more at the code level, where you've made choices at a code level, which is less of an architectural concern, and you're pushing more into the, okay, what should I do in terms of looking at the kinds of changes that the business is asking for, and what is it about the system that is making it more difficult than we thought it should be, and then using that as your guidance for what needs to change. Another common thing that happens is systems that didn't used to care about each other now become important in the same kind of flow, and so you've got to bring systems into alignment that didn't used to have to cooperate with each other. And that's very often, if you had one system that got to think it was in its own little world for whatever reason, and now all of a sudden it has to play nice with everything else, you probably made assumptions in the construction of that system that means you're not encapsulated quite the way you should be, and the proper things aren't exposed because you had this wonderful little dream world where you didn't have to talk to anybody. That's probably the most catastrophic thing that could happen in that context, is the business completely reorganizes its flow, and now all of a sudden systems that used to not care about each other really do have to care. And then you just have to, okay, what kind of scaffolding do I have to put around this to allow system B to talk to all of these other things that it never needed to worry about before? So I think that's the most common path you would get there, unless it's just an accretion of code problems that you haven't had to worry about. Yes.
Sorry, I think that's going to be the last question.
Okay.
You were talking about the contract test,
Mm-hmm.
and how it tells you what assumptions a system that uses you, for example, has made about you.
Mm-hmm.
Does that imply that it's the people who write that system who would have to write the tests for your contract?
That can vary, but generally, it is most useful for the person who is using the system to write those tests, because they can see, okay, what are the impacts of the responses I'm getting from this system to me, and so that's generally where it would be driven from. And it's the way we generally look at this is it's basically data in, black box miracle occurred, something comes out. And all I care about is what is the consequence of the action that I have set in motion, and does that match my expectations? And so I'm in a better position to write that. Now, it could be, if what you actually have is a pipeline, that it might be easier for the receiving system to write the test, because it understands what the mapping is from input to output. So it does depend on the situation, but if I'm requesting information from you, I'm probably in a better place to write the test. If I'm giving you an action and you're giving a response to somebody else, you're probably in a better position to write the test. Okay, well, thank you very much.
Thank you very much for the discussion. We'll be outside for there will be some time for networking outside, and there will be also some drinks. I think that would be a chance to talk to Rebecca and ask questions. Thank you very much for coming, and hope to see you next time.
And the slides will be available somewhere.